Okay, class, so next we're going to be doing chapter 5. It's called Investment Decisions, Looking Ahead and Reasoning Back. In this chapter, we will be looking at the investment decisions of businesses. I know a lot of you guys contacted me on some of the formulas here. I'm going to go ahead and go through the formulas really well so that you guys can easily understand them because they're really quite easy. All you have to do is just use the information within the problems in order to help solve. So for 5.1, lesson 5.1 is called compounding and discounting. So when you invest, you have to consider a few things. These things include if you should invest how you invest now so you can gain more in the future, or if you shouldn't invest at all and just keep your money now to spend. When we use compounding and, okay. Alright guys, so now we're going to go into chapter 5. It's called Investment Decisions, Looking Ahead and Reasoning Back. In this chapter, we will be looking at the investment decisions of businesses. So to begin, we're going to start with lesson 5.1. It's called Compounding and Discounting. And it's basically talking about that, like how you have to make decisions depending on if you're going to invest or not. So when you invest, or when you want to decide if you should invest or not, you have to consider a few things. These things include if you should invest now so you can gain more in the future, or if you shouldn't invest at all and just keep your money to spend currently. We can use compounding and discounting to help out with our decision making. Discounting is when you determine the present value of a payment or payments that are to be received in the future. Or in other words, you're finding the present value of a future sum of money. The formula for discounting is present value, or sometimes net present value, with future value divided by 1 plus r to the power of k, where PV or NPV is present value, because that's what you're trying to find. FV is future value. R is your interest rate, your current interest rate, and K is the number of years, which sometimes I may use N to denote that. So if I use N or K, just know that I'm talking about the number of years, because usually we use the letter N. So this is what discounting is. It's basically finding the present value of a future sum of money. So you have some money in the future, and you're going to actually try to see how much it is worth today. The formula for compounding, on the other hand, is FV equals PV times 1 plus R to the power of K. So it's just a reverse of this one, all right? Where FV is future value, PV is present value, R is interest rate once more, and K is the number of years, okay? So compounding is the constant accumulation of money where the interest earned remains in the account to earn more interest in the future, okay? So it is the constant accumulation of money. So you have invested some money today, and you're going to actually see what the future value of it is in, let's say, around 10 or 12 more years. So an example of compounding would be, what would be the future value of $100 in 10 years at a 5% interest rate. Okay, so remember, our compounding formula is FV equals PV times 1 plus R to the power of K. Okay? Remember, if I'm asking what is the future value, you automatically know that you're compounding because you're trying to find what FV is. So in this case, we want to find out what the future value of $100 will be in 10 years at a 5% interest rate currently. So we do FV, since this is what we're trying to find, equals the present value of $100 times 1 plus 0.05 to the power of 10, okay, because it's 10 years that we're looking at. The 0.05 is the interest rate, 5%. All right, so now FV equals $100 times the 1.05. I went ahead and added that together to the power of 10. Now remember, please excuse my dear Aunt Sally. That's why I went ahead and did what was in parentheses first. Now please excuse. Excuse is for exponents, so I'm going to go ahead and do exponents next. So FV equals $100 times 1.628, because when you bring 1.05 to the power of 10, it gives me 1.628. Now I'm going to go ahead and multiply the 1.628 times 100, and that gives me approximately $163, okay? So this is a simple compounding problem. Remember, I will be including all of these worksheets as well, so you guys can look at these in more detail. A discounting problem, on the other hand, this is how it would be worded. How much would you have to invest today in order to earn $200 in the future if interest rates were 5% and the time span was 10 years? And please, I apologize for my writing, but hopefully I am articulating very well so you guys can actually understand what I am writing as I speak. So, this question asks, how much would you have to invest today? So remember, with discounting, we're trying to find the present value. How much would you have to invest today in order to earn $200 in the future if current interest rates were at 5% and we're giving you a time span of 10 years? So in order to get $200 in 10 years with a current 5% interest rate, how much money do we have to invest right now? So remember, the formula is present value equals future value over 1 plus r to the power of k. So PV equals the future value of $200 divided by 1 plus 0.5, because that's our interest rate, to the power of 10, because it's also 10 years. So PV equals $200 divided by 1.05. I went ahead and added those together to the power of 10. From the other equation, we remember that 1.05 to the power of 10 equals 1.628. We divide that by $200, so the present value is $123. So if we want $200 in the future of 10 years at a 5% interest rate, we're going to have to invest $123 today. Okay? That's all that's telling us. Also, as a bonus rule of thumb, I usually don't give problems that have anything to do with the rule of 72. 72. But if you guys just kind of want to know, the rule of 72 is when you invest at an interest rate of, let's say, 10%. You divide that by 72 in order to get the number of years that it's actually going to take to double your money. Okay? And that should be maybe 5 years in this scenario. Okay? So that's just the rule of 72. Don't quote me on that math, though. All right, now on to the very next section, 5.2, how to determine whether investments are profitable. Now we will be discounting in order to determine whether an investment is profitable or not. In order to do this, we must talk about net present value, investment in capital, and the cost of capital. And remember, guys, whenever you talk about capital within economics, we are talking about equipment,